Network Plus course. TX or X reverse. When connecting from a PC type device into a switch for the PC, use pins 1 and 2 to transmit and 3 and 6 for receiving a digital signal. This means that the pins must be reversed on the switch using pins 1 and 2 for receiving and 3 and 6 for transmitting the digital signal. If your connection isn't working, check the cable end pinouts, bent pins. Many of the connectors you will encounter have small pins on the end that must go into specific holes on the interface to which they plug. If these pins get bent, either they won't go into the correct hole or they won't go into the hole, period. When this occurs, a cable either will not work at all or will not work correctly. Taking care not to bend these fragile pins when working with these cable types will prevent this issue from occurring. Bottlenecks. Bottlenecks are areas of the network where the physical infrastructure is not capable of handling the traffic. In some cases, this is a temporary issue caused by an unusual burst of traffic. In other scenarios, it is a wake-up call to upgrade the infrastructure or reorganize the network to alleviate the bottleneck. The obvious result of a bottleneck is poor performance. Fibre cable issues. Fibre is definitely the best kind of wiring to use for long distance runs because it has the least attenuation at long distances compared to copper. The bad news is that it's also the hardest to troubleshoot. Here are some common fibre issues to be aware of. SPF GBIC cable mismatch. The small form factor pluggable SFP is a compact, hot, pluggable transceiver used for networking with other types of equipment. It interfaces a network device motherboard for a switch, router, media converter, or similar device to a fiber optic or copper networking cable. Due to its smaller size, SFP obsoletes the formerly ubiquitous gigabit interface converter GBIC. So SFP is sometimes referred to as mini GBIC. Always make sure you have the right cable for each type of connector type and that they are not mismatched. Bad SPF GBIC cable or transceiver. If your link is down, verify that your cable or transceiver hasn't gone bad. I have covered the price equipment you need to get this done in chapter 18. It can provide exact locations the problem has originated. Wavelength mismatch. One of the more confusing terms used regarding fiber networks is wavelength. Though it sounds very complicated and scientific, it's actually just a term used to define what we think of as color of light. Wavelength mismatch occurs when two different fiber transmitters at each end of the cable are using either a longer or shorter wavelength. This means you've got to make sure your transmitters match on both ends of the cable. Fiber type mismatch. Fiber type mismatches at each of the transceivers can cause wavelength issues, massive attenuation and dB loss. Dirty connectors. It's important to verify your connectors to make sure no dirt or dust has corrupted the cable end. You need to polish your cable ends with a soft cloth, but do not look into the cable. If the other end is transmitting, it could damage your eyes. Connector mismatch. Just because it fits doesn't mean it works. Make sure you have precisely the right connectors for each type of cable end or transceiver. Bend radius limitations. Fiber, whether it's made of glass or plastic, can break. you need to make sure you understand the bend radius limitations of each type of fibre you purchase, and that you don't exceed the specifications when installing fibre in your rack. Distance limitations. The pros of fibre are that it's completely immune to EMI and RFI, and that it can transmit up to 40 kilometers, about 25 miles. Add some repeater stations and you go between continents, but all fibre types aren't created equally. For example, single mode can perform at much greater distances than multi-mode can, and again, make sure you have the right cable for the distance you'll require to run your fibre. Unbounded media issues wireless. Now let's say your problem-ridden user is telling you that only a wireless connection, well, you can definitely take crosstalk and shorts off the list of suspects, but don't get excited, because with wireless you've got a whole bunch of possible physical layer problems to sort through. Wireless networks are really convenient for the user, but not so much for administrators. They can require a lot more configuration, and understand that with wireless networks you don't just get to substitute one set of challenges for another. You pretty much add all those fresh new issues on top of the wired challenges you already have on your plate. The following list includes some of the new wireless challenges. Interference. Because wireless networks rely on radio waves to transmit signals, they are more subject to interference, even from other wireless devices like Bluetooth, keyboards, mice or cell phones that are all close in frequency ranges. Any of these, even microwave ovens, can cause signal bleed that can slow down or prevent wireless communication. Factors like the distance between a client and a wireless access point, WAP, and the stuff between the two can also affect signal strength and even intensify the interference from other signals, so careful placement of the wireless access point is a must. Device saturation, bandwidth saturation. Clearly it's important to design and implement your wireless network correctly. Be sure to understand the number of hosts that will be connecting to each AP that you will be installing. If you have too much device saturation on an AP, it will result in low available bandwidth. Just think when you're in a hotel and how slow the wireless is. This is directly due to device bandwidth saturation for each AP, and more APs don't always solve the problem. You need to design correctly. Simultaneous wired wireless connections. It's not unusual to find that a laptop today will have both a wired and wireless connection at the same time. Typically this doesn't create a problem, but don't think you get more bandwidth or better results because of it. It's possible that the configurations can cause a problem, although that's rare today. For instance, if each provides a DNS server with a different address, it can cause some name resolution issues or even default gateway issues. Most of the time it's just causes confusion in your laptop, which will make it work harder to determine the correct DNS or default gateway address to use. And that's possible for the laptop to give up and stop communicating completely. Because of this, you need to remind the user to turn off their wireless when they take it to their office and connect it to their dock. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.